Wonderful opportunity to present our work. Now let's begin with our presentation. This will be the outline of our presentation. First, we will talk about our background study, where our research will be applied. Then we will move on to talk about the methodology, and then we will discuss our sample results. So, what is image captioning? Image captioning is a broad field of describing the image in textual format. It is a field that is a combination of computer vision and natural language processing. I think Sir talked a lot about computer vision earlier. So, computer vision is also the field of artificial intelligence that is used uh, to detect or extract the feature from the image. It is mostly applicable in the field like object detections, image recognitions, image classifications, and natural language processing is mostly used in the language processing or text processing field. Its area of applications are sentiment analysis, machine translations. It is also application in our captioning project. Now coming back to our research works, most of the image captioning tasks has been done in English language, and some of the works that has been done in Nepali language are for generating shorter captions. And those models have some demerits too. They could not generate longer and coherent captions, and they lack the detailed explanations of the image. So how do we try to eliminate is we first basically try to use longer captions. We have also used supervised learning techniques, as I have already discussed, and we'll try our model LSTM. So our objective of this research work will be if there are no already available data set in Nepali language for image captioning, we first try to curate the data set in Nepali language, and then we try to generate the captions in Nepali using LSTM. So where our research will be applied? Firstly, it will be used in the for the people who are visually impaired, and especially Nepali language speaking people. They can understand the image that is in front of them in a detailed way by using our model. And it has quite a good application in social media sites, such as while sharing the image, they can automatically generate the captions in Nepali language. And our model can be extended to medical field also if we train our model in datasets of X-rays and CT scans. Another application that will be very much helpful will be on Nepalese e-commerce site. They can generate the description of their product in Nepali language by using our model. So these are our top related works that has been done earlier. The first work is the hierarchy approach for generating descriptive image captions. It has used the technology of hierarchy recurrent network, and it can generate a paragraph level caption, but it is mostly focused on English language. And regarding Nepali language, first work was actually done as Nepali image captioning by using the technology CNN plus GRU. And it has also the demerit of, as I have already told, it could only generate a sentence level captions. And then the CNN transformer based architecture that was used earlier, using the technology of ResNet 11 or efficient net V0 post transformer, it was trained on Flickr LK dataset and could only generate shorter captions. Related works have been done in Hindi language also. They have used VGG 16 plus LSTM as their architecture, and they have generated the captions in Hindi language. So, what is the dataset that we are going to be using our project? Firstly, we want our project to be more general and also more applicable to cultural heritage site of Nepal. For our model to understand the general objects and general environment, we have used Stanford paragraph caption dataset. We have taken the dataset from their official website, and it contains 19,561 images along with their paragraph length caption, and it can describe the event, it can detect the object, it can capture the environment. These datasets are capable of that, and for our model to learn about the cultural heritage site, especially that dataset lacks cultural images mostly, and we want most of the cultural heritage site of our Nepal to be recognized by our model. So we have taken the image of about 1,000 images of different cultural heritage site. I think our image mostly include of Pashupati, Lumbini, Patan Darbar Square, Kathmandu Darbar Square, Somnath, and we have written paragraph length captions of each image. And all the dataset that we have obtained till now are in English language. So to obtain the Nepali form of those captions, we have used Google Translator API. And Google Translator API obviously has some mistakes related to grammar or coherency. And we check those captions and manually correct it and obtain the final format to that of Stanford paragraph caption. This is one of our caption pre-processing sample. I think it is Pashupatinath temple. Because writing captions in Nepal is so tedious, so we try the approach of writing it in fast English language, and we translate it by using Google API, and we correct it if any mistakes. I think it has mistakes related to stop words. I think after Chaman it is not giving stop words, and it has problem with coherency, and it is using different words but same objects in different scenario. So we want to bring the uniformity of describing the same object in different images so that our model will not get confused with the objects. And this time for dataset captions are already in English language, and we translated those in the same manner. So how we are going to make our model? First we have the caption in Nepali and the image is our dataset. The caption in Nepali are passed to the embedded layer to obtain the embedded vector, and the image are passed to the pre-trained CNN network. Here we have used ResNet 152 version 2 architectures. From there, the feature vector of size 2048 is obtained by extracting the features from there. And these two vectors are passed to the similarity matching networks. From there, the vector obtained from the embedded layer and the vector obtained from the feature vector are matched or similarity as in the encoder architecture, and they are passed to the LSTM decoder to decode the generated sequence into the text. It is passed to the linear dense layer, and after passing to the softmax layer, the predicted caption is combined to obtain in Nepali language. So regarding feature extraction part, we have used ResNet 152 version 2. It utilizes the technology of depth-wise computations and point-wise computation. What it basically does is it tries to richly generate the features that are present in the image, like I have already told, objects, the relationship between objects, or like environment that are present in the object. I think earlier someone was talking about the specific region of interest. Mm. It was proposed by Callier in their research of deep residual learning for image captioning. The model was actually trained on ImageNet dataset of 1.2 million, having 1,000 classes, and it has an accuracy of 92.06%. The input size for that model is 224 into 224 pixel. So long short-term memory, we have talked about what will be work as in decoder. It is LSTM. I think it is a sequence processor that is based on encoder-decoder architecture. We have talked about encoder earlier. That is the feature extraction part, and in the decoder we will be using LSTM. It is more efficient than RNN. We have compared it because we have to generate a longer captions, and captions are long range dependencies. The dependency comes here. This is the dependency. And for LSTM layer, we have used 256 layers because one of the longest captions, the paragraph caption of the image is of length 256 words. So we have used LSTM layer of 256, and the captions that are shorter than 256 are made of similar length by using paired sequences. So now we are coming back to moving to our result and discussion sections. We have trained our models to different epochs by giving checkpoints. We have this is the graph about loss curves. I think the validation loss and the training loss. After epoch 40, the model started to overfit on the training dataset, and we kept the checkpoint after at 50, 60, and 70 epochs. And after 70 epochs, the loss started to increase a lot, and we stopped the training process. At 50 epochs, we found the model give optimal result. I think the way to check our generated caption is by human intervention. We check the generated captions, and by using PLU score, we find that model 50 is most optimal. So how do we measure that our captions are generated? We basically used BLU score. It stands for bilingual evaluation understudy. It measures the metrics or the output in range of 0 to 1. 0 means basically the model is not recognizing what is present in the image. 1 means it is actually matching with the original caption. And the score of between 0.5 0.6 is actually is good, but it lacks the capacity of coherency and some grammatical mistakes. BLU utilize the technology of n-grams. Uh, this is the table of our result. We have used batch size of 64, and we trained our model at different epochs. 25, 50, 60, and 70 epochs also. We found very good BLU score at epoch 50, and we have used that model as our reference model. So now let's discuss about our sample outputs. It is one of our good sample. It is the temple. I think I don't know the temple name. It recognizes it. It is a temple. There are lots of people there, and the sky is blue. Then there is a tree around. It is saying that same in the Nepali language. You can also read there. It is one of our fairly good example. Though it is recognizing the environment, it is saying Mandir Rato Ital Baneko Cha. I think it has recognized the object, but actually it is not the temple. It is saying it is a temple, it is the foreground of the temple. Okay. It is one of the bad sample output from our model. Though it has recognized or say it is a people here, it is actually the image of woman's body carved in the one of the wall of the temples, but it says it's of sheep, goat. I think there is problem with recognizing the object there. So now let's talk about what is the conclusion, what is the research gap we have contributed here by using our models. We have trained our LSTM models with different BLU scores were obtained. The main problem that we found in captioning by using Nepali language was that the Nepali language is grammatically complex and morphologically complex also, and the results contain some grammatical errors, and that will be improved by using higher architecture like transformer. Actually, transformer could improve that. And as deep learning models, they are always data heavy. They need more data set. I think mostly on image, cultural heritage site image, more data sets should be needed. Regarding our research contribution, I think it is we have a multi-modal. We have Gemini, we have BARD. We can upload the model there and get the description. But most of the models, they are foundational model. They are trained in English language. I think this will be the path for training such foundation models, not that big or things. Train in our original Nepali language so that they could capture the original grammatics, semantics that are present in Nepali language context. These are our reference work that we have used. Thank you. If you have any questions, I'll be okay.
Okay. Thank you, Nawaz Reddy, for your nice presentation. Now, I would like to.
So thank you for your wonderful presentation. So hopefully this is also one of the application of artificial intelligence combining natural language processing with the computer vision. So that is the powerful approach in deep learning. So in your graph and loss graph. So how I want to know how you divide the data set. How training data set, and testing data set. How you divide that?
Sir, I forgot to tell about that. We actually split that in as 70, 15, 15 as training, test, and validation. That is it.
I want that answer. So for any approach, so that is the best to divide data set into training, testing, and
Yeah, we have done that.
I hope question from the Vinod in order to motivate Nauraj Trivedi. No question. Any other question?
I want the question also.
From the students?
so you need to ask to your friend question, so he can improve in the future, and it will also be useful for you.
Okay, thank you very much. Yeah. Today in this session we have around 5 presentations. I think all the presentations are interrelated. From this session,